Hey everyone, welcome back. In this video, we're going to focus on Python concepts, variables, and data types. You can think of Python, or really any computer programming language, as a set of instructions to the computer to do something specific. This is what we mean by computer code. This code we write is interpreted by the computer to do very specific actions. This mechanism in Python is referred to as the interpreter. Before diving into writing Python code, we should start by discussing one of the fundamental concepts of programming in Python, variables. Variables in Python can be thought of as labels to containers of information. This is the concept of a pointer. A computer will store information in its memory that it can look up when needed. To keep things simple and easy for humans to follow, Python uses variables to reference that information. You can think of Python variables as labels point to where data are stored memory. These variables give us the ability to relabel data so that we can easily access the information. Variables can store values of any data type. A data type is an attribute that describes a piece of data based on its values, its programming language, or the operations it can perform. In Python, this includes strings, integers, floats, lists, dictionaries, and more. We'll explore these data types throughout the course. Naming variables is important because these names are reminders for yourself and others about what you are storing in the variable. Recalling the data type also helps you understand what the data can and can't do. Next, consider how you will assign expressions, which can help make your code more concise. An assignment describes the process of storing a value inside a variable. And an expression is a combination of numbers, symbols, or other variables that produce a result when evaluated. Now, let's examine that in Python. Let's start with a list of the ages of the starting 5 players on a professional basketball team. We'll assign the list to a variable called ageList. Notice that we didn't call it, for example, x, because x doesn't tell us anything about the value it contains. And if we encountered an x later, we might not remember that it's a list of ages. One nice thing about Python is that the computer interprets the data type for us automatically when we assign a new variable. This is called dynamic typing. Dynamic typing means variables can point to objects of any data type. Also, there are no default types for most new variables, so we need to assign or initialize before calling them. Let's return to our example. We'll find the maximum age of the basketball players by using Python's built-in max function and passing our age list to it as an argument. We'll assign the result to a new variable called maxAge. When we call the variable, the computer returns a value of 34. This is an integer, so the maxAge variable contains a value whose data type is integer. Now suppose we want the maxAge variable to contain a string value. We can convert it to string by using the string function, represented by str, and reassigning the result back to the maxAge variable. Now our variable has a data type of string, which is indicated by the quotation marks in the output. You'll learn more about strings later. For now, just remember that those quotation marks are unique to strings. We can also overwrite the contents of the variable entirely, if we want. For instance, we can store in it the text string 34. Now, when we call the variable, the computer returns our new string. There are a couple of important things to note here. First, notice that when we converted maxAge from an integer to a string, we reassigned it back to itself. If we hadn't done this, and we had simply used the string function on the maxAge variable, the computer would have returned a string, but the contents of the variable would not have changed. Generally, when you want to modify the contents of a variable, you have to reassign it. The second important thing to be aware of is that the order that you run your cells matters. For example, if I rerun the cell where I first assigned the maxAge variable and then call this variable in a new cell, you'll notice that its value has reverted back to the integer 34. It's no longer the string 34. In these examples, the value contained in the maxAge variable changed every time we reassigned it. That's why it's dynamic. Variables are convenient because you can refer to them instead of the values they contain. So if we define a new variable that contains the minimum age in our list of ages, We can subtract the two variables to find the age difference of the oldest and youngest player. Just remember that if you want to modify the contents of a variable, you usually need to reassign it. It's also important to consider that the order you run the cells in matters when coding in Jupyter Notebook. Python has certain spelling or grammatical rules to follow just like any other language. In programming, we call these rules naming conventions and naming restrictions. Naming conventions are consistent guidelines that describe the content, creation date, and version of a file in its name. Naming restrictions are rules built into the syntax of the language itself that must be followed. In Python, there are some important naming conventions to keep in mind. One of these is to avoid keywords. A keyword is a special word that is reserved for a specific purpose and that can only be used for that purpose. You've already encountered some keywords, such as for, in, if, and else. There are others too, which you'll learn about soon. Keywords should never be used when naming variables. Thankfully, you don't have to worry about accidentally using a keyword. First of all, keywords will appear in a special color in most coding environments. So a good rule to follow is that if you're naming a variable and the name changes color, don't use that name. And if you try to assign a value to a keyword anyway, the computer will throw an error. Python will let you make spelling mistakes, but it won't let you use a keyword for a variable name. To sum up, a big thing to keep in mind regarding variable naming conventions is that you don't want to use reserved keywords or reserved functions, for example, print and str. Precision is essential when programming. This is why there are naming restrictions for variables. For instance, variables can only include letters, numbers, and underscores. This means you can't use spaces, tabs, or special characters, such as the $sign or ampersand. Another rule to keep in mind is that, while variable names can contain numbers, they must start with a letter or underscore. Also, Python is case-sensitive, which means capitalization matters. Lastly, variable names cannot include parentheses. This is because parentheses have other uses in Python. A key part of working with Python as a data analytics professional is being able to effectively name your variables to create meaningful code. Let's review some examples of effective and ineffective variable names. We have a lot of flexibility in naming the variable, but there are some rules. The first thing you can't do is have spaces in your variable name. This makes sense because it looks like there's 1, 2, 3 different names here. But you'll see if I run this right here, we get a syntax error basically saying that, hey, Python says we can't do this. Instead, there's a few ways we can do things instead of spaces. One such method is using snake case. Snake case is by replacing the spaces with underscores. Each word is separated by this underscore. You can see I have no issues here. Alternatively, to make it still readable but removing the spaces, we can remove the spaces but then have the first letter of each word be capital, just so it's a little bit easier for us to read. This is usually referred to as camel case. However, in Python, snake case it is much more common. You can see here again, no error. Another variable naming rule is you can't use special characters. Python recognizes several special characters that have very specific meanings, and you often get error. For example, this ampersand here in the middle of a variable will not work, and we get an error. Another convention is writing a code with logical names for a variable. Although you can name your variable for something very short, it can be difficult to read if your variable names are not very descriptive. S, for example, is equal to 720, and it's not super descriptive. It's still a valid variable name. But by convention, it's usually better to say what the variable is supposed to represent. In this case, it should be represented as seconds. That give a little more context when you're reading your code. You can also use numbers inside your variable names. For example, we have here sales in 2025 for a common naming convention. You can put that in Python code and have no issues. However, variable names can't start with number. You can see here if I start with a number, we'll actually get an error within Python trying to name that variable. It's good to keep these rules and conventions in mind as you name your variables because they'll help your code be organized and readable. Okay, now let's go back to parentheses to understand more about how these function in Python. When doing calculations, the rules for parentheses follow the mathematical order of operations. For instance, if we input 3 times 4 plus 5 in parentheses, Python will read 4 plus 5 first because it's following the order of operations. This is equal to 27, but 3 times 4 in parentheses plus 5 equals 17. That's because the operation within parentheses will always be completed first. By the way, if we don't use any parentheses, Python will follow the standard mathematical order of operations. That's all for now. Don't forget to smash that like button, subscribe, and ring the bell to stay updated. In the next video, we will learn more about data types and conversions. Thanks for watching, and see you there.